In this question, obtain the expression for the ratio of the de-Broglie wavelength associated with the electron orbiting in the second and third excited states of hydrogen atom. Okay, so de-Broglie wavelength associated with the electron in second and third excited state. Second excited state. So second excited state, that means the value of n should be equal to 3, and third excited state, means the value of n equal to 4. Okay, so now that means third orbit, and it is we're talking about third orbit and fourth orbit. So what is the ratio of de-Broglie wavelengths corresponding to these third to fourth? That means de-Broglie wavelength corresponding to third orbit and de-Broglie wavelength corresponding to fourth orbit, that we have to find out, and we'll be taking the ratio of these two. Okay, so then now question is that what is the de-Broglie wavelength? So we know that according to Bohr's atomic model, the circumference of electron orbit is always an integral multiple of de-Broglie wavelength. According to Bohr's atomic model, okay, the circumference of the electron orbit is always an integral multiple of de-Broglie wavelength. Okay, that means circumference, how can we write that one? It will be 2 pi r equal to n lambda. Okay, so this is the formula. So if we want to write that one in terms of nth orbit, so it will be 2 pi rn equal to n lambda n, and this is. So now what we'll be doing, so for lambda 3, the value of lambda 3 from this formula, ये formula से lambda 3 का value अगर हम लिखेंगे, so it will be 2 pi r3 divided by so here lambda 4, the value of lambda 4, it will be 2 pi r3 divided by 2 pi the value of lambda n. तो यहाँ से lambda n का value पहले लिखना, lambda n का value कितना होगा? 2 pi rn upon n. Okay, so 2 pi r3 divided by value of n is 3. Then what is the value of lambda 4? So lambda 4 will be 2 pi r4 divided by 4. Okay, so this is how first we need to write down the formula. पहले formula लिख लेना है, फिर उसके बाद जो करेंगे. Okay, so see, you can see how what is the chance of mistakes. अगर हम formula नहीं लिखते तो यहाँ पे अगर डायरेक्टली ऐसे लिखते तो आंसर विल गेट द आंसर, हम लोग को आंसर मिलेगा, बट दैट विल बी द रॉन्ग वन. तो इसलिए पहले फॉर्मूला लिख लो और उसके बाद जो भी कैलकुलेशन करना है कर सकते हैं. सो लैम्डा 3 अपॉन लैम्डा 4 कितना होगा? सो 2 पाई विल गेट कैंसिल आउट. सो r3/3 डिवाइडेड बाई r4/4, दैट मीन्स इट विल बी 4/3 होल इनटू r3/r4. ओके, सो इट विल बी 4/3 रेडियस of the third orbit का रेडियस कितना होगा? So we know for n radius of nth orbit how much? 0.53 n square by z. Okay, 0.53 into n square, this much angstrom. So 0.53, तो radius of third कितना होगा? 0.53 into n square means 9, that will be taking. एंड r4 का वैल्यू कितना होगा? 0.53 इंटू n square means 16. So directly we will not do the multiplication, we will be writing as we are taking the ratio, so we can write it like that. So the value of r3 is 0.53 into 9 divided by it will be 0.53 into 16. So 0.53 will get cancelled out. So 3 is a 9 and 4 is a 16. So it will be 3/4. So ratio of lambda 3 to lambda 4 wavelength corresponding to third and fourth orbit or second excited state to third excited state will be 3:4. This is the final answer.